YouTube. In this video, we're going to be solving a right triangle, but in order to find a specific value and not all values of the right triangle. But we are going to be using right triangle trig to accomplish this task. In this case, solve for x in this diagram. So let's read what we have here. It says, consider the circle in the following figure has its center at point C, so we have center here, and a radius of 18 inches. We can see that there are two radii emerging from here that are shown, and they're both 18 units long, 18 inches. It says if the triangle ADC, so we're looking at this larger right triangle, ADC, is a right triangle and A is 35 degrees, find x, which is the distance from A to B. Now, when you see diagrams like this, which you see from time to time, kind of a compound picture because you have a circle with a triangle and that's supposed to confuse me, right? This is a trig video, so I'm going to focus on the triangle, and I guess what I'm saying is whenever you have a compound diagram like this, it's good to kind of draw your triangle off on the side and kind of clean it up a little bit. So if we were to look at the same triangle, draw this in over here, we know that we have a right angle here, and this is down here at vertex D. We can even label it the same way. We had A, D, C. And of course this point B here on the outside, I'll put that in there, but only kind of to showcase what we know here, and that was this. We know that this is 18. We know that the distance from B to C is 18 units, and we know that the distance from A up to B is x units long. So instead of writing this as x and 18 and this 18 here, what we're going to do is we're going to use a segment addition postulate that you remember from geometry that says, look, if the distance from A to B is x and the distance from B to C is 18, then the entire distance from A to C is the addition of these two segments. So instead of writing those separately, what we're going to do instead is we're going to write them algebraically like this. We could say that this is x plus 18 units. That is the length of this entire side. Okay, and of course, we also know that this is 35 degrees. So our job in this case is to determine what the heck x equals. And so the question becomes, could we do this using right triangle trig? And I suppose we could. As a matter of fact, the question becomes, now, what could we relate this angle that we know, by the way, 35 degrees, which would also, by the way, tell us that this top angle here would have to be 55. Remember that those have to be complementary. But anyways, that would relate this 35 that I know to this 18 that I know to this x plus 18 that I don't necessarily know, okay? And so we say, what trig function would relate this angle that I know to these two sides? It looks like we have opposite over hypotenuse, so that is a SO or sine case. So we're going to go and write this out. We say sine of angle A, which by the way we know the measure of. So we say sine of a 35 degree angle, in this case equals the opposite, 18 over x plus 18. Okay. So now our job is just to do algebra. And as a matter of fact, that's what a lot of this is, setting up a situation then doing algebra. The trig part was very small. We've done that part. So our job now to get x by itself, how can we do this algebraically? Now there are a few methods we could use. One method might say, well, two equal proportions here, let's do a cross product, okay? And then we'll solve for x. Or another person, you might hear me say this, you say, well, I noticed that x is in the basement over here. This is the method that I would probably use. I would reciprocate both sides. I would say, if I take the reciprocal of the left-hand side and it's equal to the right-hand side, we have to take its reciprocal also. So we'd say this would be x plus 18, and this would be all over 18, okay? And, I suppose we could multiply both sides by x plus 18 as well, just to show you that that would have canceled with that. And you'd have to take the left side times this as well. But I'm going to avoid doing this. And the reason why is because I think my method is the cleanest. And that is, if you ever have your unknown that you're solving for in the basement, you could reciprocate both sides of the equation and still have equality. And the reason why I said I want to do this is because now, to do my algebra, I'm going to take both sides times 18. And so the right side, that cancels out, and we're left with just x plus 18. Or unknown plus 18 inches. And then on the left side, remember you multiply fractions straight across. So on the top, we get 18 times 1, or 18. And in the basement, we still have this sine of 35 degrees. So what we're going to do now is we're going to simplify this further. We need to get the x by itself, which means this 18 needs to be subtracted. So what we end up with is this here. We say x, I know this looks messy, but we have 18 of these sine 35 degrees, and this was minus 18. What we need to do now is kind of just evaluate the left-hand side. So in order to find out x, what we're going to do here is we just get our calculator out. And it seems to me, order of operations, that we should likely take care of this 18 divided by sine 35 first. Now, the unfortunate thing is that sine 35 on this calculator, I have to type in 35 and then hit sine. Make sure you're in degrees, by the way. Your calculator's in degrees and not radians. But I have the sine of 35 here. I need to take 18 divided by this. So what I'm going to do is I'm actually going to hit memory plus and store that. And then I can hit 18 divided by memory recall. And I get this value right here coming out to be 31.382. Now, I don't want to round this until the final step, so I'm actually going to leave this. I'm going to say, now take my answer. We're going to subtract 18 off of this. We end up with this right here. So we would say x is exactly this entire decimal, but we can only write a few decimal places. So we're going to say about 13.382, and we say 13.382, and we were measuring in, it seems to me, I think we were measuring in inches here, so inches, and this is x. And so the last thing I want to do, anytime you solve a right triangle, or anytime you solve a triangular situation, I suppose I'm going here, is we want to go back and put it in the image, in the diagram. Okay, so 13.382, and I, of course, know that this isn't drawn to scale, but, you know, we say, well, would this be reasonable? Okay, and if you were to combine these two, by the way, 13.382, Maybe actually I'm asking for the distance from A to C, and I'm not in this problem. Don't worry, I'm asking for the distance from A to B, x. But if I was asking for A to C, we'd actually have to take this number 13.382 and plug it back in and add it to 18. But if we were to take that now and add 18 to it, okay, we get an entire side length of about 31.38-ish. And when you look at the grand scheme of things, it has to be the longest side, and that's an entirely reasonable number to get for a hypotenuse. So that's more right triangle trig for you.